as we get started in the afternoon, we're going to start with another fireside chat. So I'm going to want to bring up to the stage Paul Rode, Head of U.S. Engineering at Tishman Speyer, and Zachary Steinberg, Senior VP of Vice President at REBNY. They're going to be talking about energy storage and thinking beyond operational carbon. You know, energy storage systems have the potential to provide numerous benefits for building owners that really range from increased resiliency, better energy management, and ultimately reduction of emissions. You know, what's also overlooked is, we measure, scope 1 and scope 2 emissions, and we really don't think past that. And as owners, what we need to start to do is think about the entire life cycle of our assets, from where the steel comes during the construction process to how it gets freighted over to our actual buildings, to even the refrigerant as we cool the buildings. So we're going to have, an interesting fireside chat, and then we're going to start to get into the presentation. So with that, Paul and Zachary.
Well, Paul is interesting. So why don't you tell folks here who may not know you quite so well, who you are and what you do and sort of the arc of your career?
Sure. So I'm the head of engineering for Tishman Speyer, and that job spans both new construction and property operations, and it involves looking at all the technologies, basically running the engineering teams and developing the capital and operational budgets for mostly back-of-house stuff. How I got here, interesting. I worked for Johnson Controls for a number of years doing deep energy retrofits, and that led to a few projects around the world. I was overseas a good chunk of time, and from there I went to the related companies, had a very similar job as I do now for related. I was Senior Vice President of Engineering, and actually picked up a lot of experience in the residential sector. Johnson gave me a lot in the industrial and commercial sectors, and then went to RXR from there. It's a very similar role, head of engineering, very progressive company that had no problem experimenting with things, which really broadened my experience base. And now I'm at Tishman Speyer. So we have about 200 million square feet around the country. About a third of it is here in New York, but the rest of it is all over on the various continents. And in that long line, I've done a lot of these types of projects. I have to help the teams discover what, or nominate what they want to do, originate what they want to do, and then work on securing capital for it from the investor base or from our asset managers, and then getting the items in and measuring their results so that we can do more.
So you said you were in charge of deep energy retrofits, but my guess is that was before deep energy retrofits were cool. So talk about how that work has changed over the last 15 or 20 years, or however long your career has been, and then we can get into storage and carbon and things like that.
Okay, well, deep energy retrofits went from something that you couldn't find in the dictionary, and that as defined as loosely as it was impossible to deliver. So it went from that to something that did become possible to deliver due to advancements in just analytics and in material science and installation, and in just contractors getting better at performing projects that was a little bit outside their comfort zones, and designers being more accepting of technology. So it went from something that was not defined and impossible to deliver to something that was defined and probably could be delivered, to something that could be delivered, to now it's something that can be expected in old buildings, and new buildings are pretty much targeting energy densities that they wouldn't have targeted a few years ago. In fact, the last group that needs to be brought on board are the users of the buildings.
So you mentioned a little bit about doing projects all over the country, but Tishman Speyer is all over the world. So what lessons have you learned, and I guess let's maybe pivot here a little bit to thinking about storage, to projects that you've done both in the US or elsewhere, and what you think we can learn here in New York?
Okay, first of all, I would agree that, and my European colleagues would disagree with me, but I do agree that we are on the pinnacle of, here in New York, we're at the top of the practice for energy efficiency. And storage is just a derivative of that. And I will also say that what's interesting is I only speak 2 languages, but it doesn't matter where I go. There's a common language in engineers. It's too hot, it's too cold, I didn't get my work done, the chiller's breaking down. It's amazing, it's actually amazing the similarities in how the buildings are configured. They're used differently. There's more tolerances in some countries than others over environmental conditions, but they're pretty much the same stuff exists all over, at least in the Class A assets. So, and what's interesting too is I recently had I had Era prepare a list for me of all the regulations that are coming out, all the regulatory changes like Local Law 97 here, the Boston laws, the BEPS laws in DC, and sure enough, all over the world, this is, of course, it's following the C40 path, but all over the world, you're finding regulations being set by local municipalities on carbon standards. The challenge is global, and the usage patterns are fairly similar. So there'll be a great educational base that's built up by doing the projects. And I think that I lose nothing by practicing here and bringing it elsewhere. And I picked up some items elsewhere and brought them here.
So what do you see as, we're here at a PropTech challenge about storage, let's say. So what do you sort of see as the challenges to get solved in that space? Okay. And what are you looking for when you start to evaluate projects?
Well, all right. So, when we were introduced, I heard that, storage, helps reduce emissions. Well, yes and no, right? It reduces emissions if emissions are fairly accounted for. So, here in New York and in other cities, there's like a flat rate you apply to electric or to steam or gas for the carbon in that product, the scope 2 carbon emissions. And any type of storage uses more energy, not less, on a pure BTU basis. And so, we need to see the regulators get on board with the time of day carbon, developing time of day carbon metrics and measurements for the utilities that we use. So given that, there's clearly, as a building operator, it is clearly better for me to have storage in a building, whether that's electric storage or thermal storage, advantaging some type of phase change or just some sensible difference. It is clearly a benefit for me on the operations side. It's a little more complex to run, but it is something that keeps the teams sharper and allows us to play around with the thermal inertia in the building to basically provide a better environment at lower carbon and lower cost. And I will say something too. In the past, spanning the career, the first set of challenges 20 years ago was maintaining space temperature. Then, a decade, I can't believe I'm speaking like this, I'm this old, a decade or 2 after that, the challenge was you got to maintain space temperature, but you got to do it at this efficiency point, right? So that the whole conversation shifted to the efficiency point. Now it's, you have to maintain space temperature at this efficiency point. And by the way, it matters where you get the energy from and how and when you use the energy, so it has to be at this carbon point also. And layer all that on top of a need in this industry to provide indoor spaces that are high performance spaces, meaning more air than in the past. Codes, 30 years ago were developed to keep people from dying in the spaces, right? Now we're pushing air into our buildings so that people can perform like they're athletes, at a World Cup event. And so that requires that much more fan energy, that much more cooling energy, heating energy, but it's a given we have to provide it, and we have to provide it at a point that, at a lower point than in the past, which means more use of storage and more use of heat reclaim and reuse.
So maybe let's shift for a second just to this category 4 conversation about embodied carbon and carbon capture, because I think one of the things you just highlighted in your remarks is we started talking about carbon in a way that we really haven't talked about before. And so, I don't know, I feel comfortable saying that I'm younger than you. I don't know how much, but even in my career, embodied carbon was not a phrase I had ever heard until, I don't know, 3 or 4 years ago. So when you think about that concept, what does it mean to you running engineering at a very large commercial owner?
Yeah, great question. And it's interesting. It's not talked about a lot. You'll hear a lot of companies come out with carbon, net carbon zero promises at some point in the future. And the reality is that they're talking about operational carbon. Embodied carbon is what carbon was expelled making your building. So it needs to be accounted for. I do account for it. I mean, we're all the time when we look at acquisitions, I do an embodied carbon calculation, compare the acquisitions. I compare the acquisitions to new buildings. I want to, I am making the argument, and we are, and Rob Speyer is listening to the argument, that what we don't want to do is trade a whole bunch of embodied carbon emissions for building a new building when we could have just for an existing building that's retrofitted. So there is a tease there is a balance there, and also there is an argument to be made that there's a connection between embodied carbon and scope 3 carbon, or the activities that emit by virtue of your building being there, not just myself bringing vendors in, but the tenants. And you find that older buildings tend to be in prime locations that require less commuting. So that would go into that overall carbon calculus, where the building is, how it can be configured, how densely it can be configured. And, is there a net benefit between that and a new building? Now, most of the time there's a net benefit to a new building because you can just basically get more people in the new building, but it is not something that I do to ignore knowing what the embodied carbon is for new and old.
So how do we measure embodied carbon, and why is a new building the right thing to compare it to? Well,
and measurement, there's quick estimates that can be made on massing in a building. And they're not terribly hard, and they are very useful. The further down that road you go in terms of trying to calculate something with NASA-like precision, the more I'll argue that the assumptions outweigh the benefit of the calculation. So I think that down and dirty, quick calculations can be done. They're relative to massing and construction type for embodied carbon, and they can be done. And and then there's also a lot of sequestered carbon in the building itself at something that's 40 years old, so that needs to be considered. But I mean, the calculations can be done. It gets easier every year to do them, and there's tools now that make it very simple to understand what the relative differences are.
And what do you think? I mean, I live in the world between sort of the real estate industry and the government, so I don't really know either one very well, but I sort of occupy this bizarre space in between the two of them. And I'm supposed to talk about it like I know something, which is odd. What do you think we should do with the information about embodied carbon? What does that tell policymakers or regulators, and where should that conversation lead?
Well, I mean, for new buildings, it's important to know that to force supply chains to be good about how they make things. So, I mean, there's a whole solid argument on the new building side for understanding embodied carbon and tracking it. And then in existing buildings, I mean, I think it's an important metric to estimate. It certainly should go into policy considerations. There's definitely a place for it, but it is what's complex is that you have to look at the net efficiency of the building and the amount of output the building produces from the tenants in the building. So it is important that all buildings are not the same, and the benefit to society of all buildings is not the same. So it's important to weigh those factors out.
Well, thank you for educating me on this challenge. I think carbon capture is another one that sort of fits into this bucket in my mind, where I'm not sure we talked about it 5 years ago. I'm not sure we thought of it in the context of residential or office buildings. We thought about it in terms of capture emissions from a power plant or a big industrial facility, but lo and behold, in New York City, we have at least one building with using carbon capture. And, I'm curious about where you see that technology heading, and if you think it's applicable to a company like yours.
Well, I mean, first, it's an interesting technology. It's real technology. It's been around for a while. There's different forms of capturing the carbon and bonding it and removing it. You know, one thing I weigh that question against is that you know, my first priority is electrify the buildings and let someone else worry about the carbon capture. So that's the first priority. The second priority would be, you know, buildings where I absolutely cannot electrify them because of grid constraints or capital constraints, and they have a boiler in them, and I'll do everything I can to make the boiler plant, the heating plant, as efficient as possible. And at that point, it's, you know, what do I do? Carbon capture or some sort of offset, and I'm sure that the cost, there's parity in the cost, so that's when we would look at local carbon capture. In terms of carbon capture from just air streams, I'm not sure. I'm sure there's a way of doing that. I haven't looked into that science that much yet.
So you've done some work, and I guess I have the privilege of knowing you a little bit through another hat you wear, which is your involvement in various local law implementation and working some of REBNY's committees. So do you think of carbon capture as an offset, as an avoidance, as a...
It's an offset. It's actually, there is a way to interpret the current regulations that you can, not a way, you can define it as an offset.
Okay.
And that's defined in the current legislation.
And so where do you think that, one of the things that I've heard about carbon capture is sort of, okay, well, let's prove that that carbon is really never emitted in the future once we capture it.
Yeah.
And so what do you think goes into, what have you thought through in terms of trying to solve that problem? And how would you, as a you know, real estate company, think about, well, help me prove that?
Oh, we would do due diligence, right? Where you know, how are you removing the carbon? Where's it going? Where's the ultimate destination? Just like a hazardous material, right? So we would want to know the whole chain, and we would want to buy into the accounting that is done at each step in that chain. I mean, if you're transporting something to Thailand to cast into a block, then I'm not so sure that works. But if there's some sort of, you know, logical local economy, and I hope there will be or is, then I'd be very interested in it. You know, and you know, the market, it's interesting too, you know, there's a market price for that, $268 per ton of carbon equivalent, right? That's the penalty in the law, and I'm sure there'd even be a premium paid for it, because I'd much rather say that I am doing carbon capture rather than paying a penalty. So
we'll wrap up on this, but I got to moderate a panel an hour or two ago and bore all these fine people. But one of the questions I got to ask was to folks about sort of waving their magic wand and thinking about what problems PropTech could help solve. And so if you were to sort of get your say on that question, and whether it's in the energy storage or embodied carbon space, you know, what would you like to see tackled?
Oh, I mean, first of all, there's a lot out there, and nothing is off the table. But you know, PropTech we're trying a half a dozen things at any one time. It seems to me that, you know, all of the, you know, optimization strategies are at play in PropTech. Buildings, you know, optimum start-stop, optimum operation of the building, optimizing not just the building operations, but the work order management systems. The two are sort of synchronized together. There's all sorts of machine learning and artificial intelligence type analytics that can be applied to a building to help you get more out of what you're doing, identifying waste streams, eliminating waste. By the way, something I will say is that our mission, it isn't so much to reduce energy in the buildings. Our mission is to reduce waste from the buildings, right? I'm actually fine with tenants using a lot of energy as long as none is wasted, because that's a measure of the economic output of the tenants, and I want to maximize their economic output, but I want to do it in such a way there's zero waste. PropTech can help in the areas that are oft forgotten, you know, water management, you know, optimizing use of water management, quantifying opportunities in the future, optimizing waste handling, tracking waste handling. You know, there's, as much as I love using my iPhone and feel like I'm really high tech, I get brought down to earth every time I do a building tour. And you know, when I see 90% of the points overridden, and I just see these buildings operated at the lowest common denominator, and PropTech is going to, it does help us get away from that.
Well, Paul, thank you, and look forward to hearing from all the finalists. So thanks.
Thank you.